This video is on port security. Port security mitigates threat and vulnerabilities by limiting the port to learning a maximum number of MAC addresses, configuring violation actions, aging time, and so forth. Storm control is one example. Let's talk about what traffic storm is. Traffic storm is generated when messages are broadcast on a network, and each message prompts a receiving node to respond by broadcasting its own messages on the network. This repeats and LAN is suddenly flooded with packets, creating unnecessary traffic that leads to poor network performance. Storm control is a function that can be enabled to monitor traffic levels and to drop broadcast, multicast, and unknown unicast packets when a specific traffic level called the storm control level is exceeded, which prevents packets from degrading the LAN. Storm control can be configured by using bandwidth percentage, which configures as a percentage of the available bandwidth used by the combined applicable traffic streams that are subject to storm control on that interface. And you could simply disable the storm control selectively for broadcast, multicast, or unknown unicast traffic, or any combination. Then we have loop protection for your port. Network loop occurs when a network has more than one active path carrying information from the same source to the same destination. The information loops and amplifies using the additional path instead of stopping when it reaches its destination. Loop protection performs a specified action when BPDUs are not received on a non-designated port interface. Bridge Protocol Data Unit is a data message sent across local area network to detect loops in network topologies. It's basically a check message, and if it's not received, you could choose to block the interface or issue an alarm when Bridge Protocol Data Units are not received on the port. The exchange of BPDUs determines which interfaces block traffic, preventing loops, and which interfaces become root ports and forward traffic. However, a blocking interface can transition to the forwarding state in error if the interface stops receiving BPDUs from its designated port on the segment. Usually this happens when there's hardware error on the switch or software configuration error between the switch and its neighbor. When the loop protection is enabled, spanning tree topology detects root ports and block ports and makes sure both keeps receiving BPDUs. If a loop protection enabled interface stops receiving BPDUs from its designated port, it reacts as it would react to a problem with the physical connection on this interface. It doesn't transition the interface to a forwarding state, but instead transitions it to a loop inconsistent state. But interface could recover as soon as it receives BPDUs. Then we have DHCP snooping. DHCP snooping prevents unauthorized rogue DHCP servers offering IP addresses to DHCP clients. You can prevent DHCP starvation attack and DHCP spoofing attack with this. DHCP snooping generally classifies interfaces on the switch into two categories, trusted and untrusted, whose DHCP server messages are trusted. An untrusted port is a port which DHCP server messages are not trusted. If DHCP snooping is initiated, the DHCP offer message can only be sent through the trusted port, otherwise it's going to be dropped. Or you could set a rate limit. You could also apply MAC addressing filter on your port, which allows you to block traffic coming from certain known machines or devices. The router uses MAC addresses of a computer or device on the network to identify it and block or permit the access. Traffic coming in from a specified MAC address would be filtered depending upon the policy.